Hey, geometry, here we are at the last chapter finally. At the end, you can all move on to Algebra 2. Last chapter is exploring solids, solid shapes, and some of the unusual characteristics about those. Okay, so a couple things first. These are kind of important right here. Types of solids. You have polyhedra here. A polyhedra is a shape where there's a common shape going through the entire figure. So what do I mean by that? If you look at this shape on the left, you have a rectangle on the bottom, and it kind of is the same going all the way up to the top, right? So then you have basically that shape. But that same rectangle is all the way through. On a pyramid down here, this square base of this pyramid does not transfer all the way through. As it's going up, it's coming together to a point. So it's not the same throughout, whereas the prism is. Also, on right here, you see what's not a polyhedra. Anything that's round, so a cylinder, a cone, or a sphere, not a polyhedra at all. Okay, so again, you have prisms where it's the same shape throughout, and a pyramid where it's all coming to a point, basically. All right. Some other things about solids are three things that apply to each. You have a face, that's the flat surface anywhere on the polyhedra. Again, it can't be curved. The edge is any of these lines that you see here. Those are all edges. Okay. And of course, you're probably familiar already with the vertex or the points. Any place where edges come together. So again, the faces are the flat parts. The edges are the lines that connect all the vertices, and the vertices are the points all around the shape. Now, what's kind of cool about polyhedra is all three of those, the face, the edge, and the vertices, all have a relationship numerically. So let me go find this for you. Down here a bit. Where are you? Wait a minute. Oh, here we go. They all have a relationship, and it's through Euler's theorem, where the faces, the vertices, and edges all have a relationship. And there's a formula right here. It's F plus V equals E plus 2, meaning all the faces plus all the vertices equals the edges plus 2. So we'll give you, the numbers, and they should add up to be a balance. The faces plus the vertices equals the edges plus 2. Okay, so we'll try one here in a moment. Let's see. I want to find a shape that's easy to work with. We'll try this one first, right? Because part of it, the trouble is, getting practice to count all the faces, all the edges, and all the vertices. Again, the formula is this. It's F plus V equals E plus 2. All right, on this shape here, I'm going to count the faces first. I'll go in order from left to right on the formula. So the faces are all the flat parts. So again, you can see there's a pyramid on top. There's a surface. There's one on there, 2. There's one in the back, 3, and one over here on the left, 4 faces. And on the bottom, there's the same 4 faces, but kind of upside down. So there's 1, 2, 3, and 4. So this is 8 faces. Okay. Now I can easily erase this and go, start over again. All right. Vertices, those are the points. So here's 1 at the top, 2, 3, 4, 5, and 6. I don't see any other ones. So plus 6. Now I'll get rid of all those. So I keep it all straight. Now the edges are all the lines that connect the vertices. And sometimes these are tricky. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's it, 12. 12 edges. And then you add the 2. All right, 8 plus 6 is 14. 12 plus 2 is 14. Yeah, it checks. So there's always that relationship between the faces, vertices, and edges for every polyhedra. Let's try a few others here. One thing to talk about here is cross sections of a figure. If you slice out some part of a shape, you'll get a two-dimensional shape. It's kind of easy to see, but we won't go into that in any detail with this. All right, let's try some other of these quick and then we'll let you go. We'll start with something kind of easy here. Number 16. Again, using Euler's theorem, see if it fits the theorem. Again, the equation is F plus V equals E plus 2. All right, so here we go. I'm going to do them in order again. Front face, right face, left face, back face, bottom. That's 5 faces. Now do the vertices. Those are the points. 1 point, 1 point, 2 point, 3 point, 4 point, 5 point. Yeah, 5. And the edges, again, those are all the straight lines. So 1, 2, 3, 4, 5, 6, 7, 8. 8 edges plus 2. 10 equals 10. Okay. Now just one more. It's a little more complicated. This little guy down here. Number 19. All right, again, it's faces plus vertices equals edges plus 2. Faces. Front face, back face, and then that's 2, 3, 4, 5, 6, 7, 8. I have 8 faces. Clearing that out. Vertices, those little points. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of those. And lastly, the edges. 1, 2, 3, 4, 5, 6 on the front. 6 on the back. 1, 2, 3, 4, 5, 6. That's 12, right? 1, 2, 3, 4, 5, 6. That's 18. Plus 2. 20 equals 20. Yeah, it worked. All right, folks, that's the end of geometry. Good luck.